Hello guys, welcome back to my channel. In this series of videos, we'll be looking at vectors and matrices. And we're going to be starting with the July, May, June 2018 CXC past paper. Let's get right into it. Now we start with question 10, and 10a says a transformation T is defined by matrix T equal, and of course you go row by column, right? So you have 2, -1, 2, 0. The point A, which is -2, 3, is mapped onto point A prime, which is AB, under T. Find the value of A and of B. Now, pretty straightforward. Now, T is a transformation that maps A onto A prime. Now, how do I approach that? What it means is that when I take T and I multiply it, so whenever you're given a scenario like this, what it means is that when you multiply the transformational matrix T by the matrix A, and of course I would have to put this in matrix form, by A, I'm going to end up with A prime. Now of course technically, because these are coordinates, to turn them into matrix they become like position vectors, and so you have to learn to make the connection. So when you multiply T by A, is really OA because you're taking it from the origin. And this is really OA prime, because remember, you can always convert every single point to a position vector and all position vector to a point or a coordinate. That connection is very important, all right, for how we can go from point to vectors and vectors to points. All right, but let's get right into it. So we're going to have the matrix, the transformational matrix, which is going to be 2, -1, 2, 0. Which I'm going to multiply it by A, which is -2, 3, and it's going to give me AB. So I'm not going to bring AB in because AB is the result of me multiplying these two matrices. Now, whenever we multiply a matrix, we go row by column. All right, very important for you to distinguish between your row. So you're going to multiply the row of the first matrix by the column of the second matrix. So what am I going to have over here then? All right, just follow me. To make it easy, I'm gonna take the row and put it down. So I'm gonna have 2 open bracket, and then of course the second item in the row is -1, so I'm gonna have -1 open bracket. All right, good to go. I'm gonna do the same thing with the second row. Now notice that I only wrote this once because you only have one column. I can do the same thing with the second row, which is row 2, which is 2, 0. I'm gonna have 2 open bracket plus 0 open bracket. Of course, notice normally you have a plus sign here, but we don't want to write a plus minus, because whenever you have plus and minus, it's actually negative. So that's why we have a minus sign here. And of course, since it's 0 there, we have a plus sign here. Now what goes into these brackets? The column in the second matrix, which is -2, 3. So you're simply just going to put -2, 3, -2, 3. Now, very important for me to check my answers. Notice that when you go vertical, you have the same thing in both brackets, -2, -2. When you go vertical over here, you have 3, 3 in both brackets. Very important point to note. Now, when I do this now, what I'm going to get is OA, which is a position vector, which I can turn into a coordinate. So this becomes 2, and you can put all this inside of your calculator to save you time. So you're going to have 2, open bracket, -2, minus 1 times 3. Of course, this is going to give me -4 minus 3, which is -7. Down here, 2 times -2 is -4, and plus 0 times anything is 0, so that's gone. So I'm going to have -7, -4. Now, this now is in its vector form. So as a coordinate, I can say, therefore, A prime would be -7, -4 in the coordinate system, which means that A is equal to -7 and B is equal to -4. Okay, let's take this up. It says determine transformation that maps A prime to A. Okay, I'm very happy that there's a question like this. Now, follow me now carefully. When you multiply T by A, you'll get A prime. Good. Now what they're saying is that how can you get A by doing something to A prime? Because you're trying to map A prime onto A. How can I reverse this? And once you talk about reverse and you talk about matrix, you're talking about the inverse matrix. All right. So if for example, what it means is that how do I get rid of this t here and get a here? Because a is what I want. What do I do to a prime to get a? I need to get rid of this t. Now in matrix we don't divide, because normally if this was like a regular equation, you'd have divided both sides by t. Instead, you multiply by t inverse. Alright, so you can say that a is equal to t inverse times a prime. So you have to understand the context of the question. All the question is asking you is what can I do to a prime to get a? Because it says determine the matrix that maps a prime to a. So what are you doing to a prime to get a? You already knew what you did to a to get a prime, so now you're doing the reverse. And in matrix language, that reverse is called the inverse. You multiply by the inverse. Same thing if you want to contextualize it and say that you divide, similar concept. Alright, so what do I need to do? I need to find the inverse of t. Alright, let's go. Now, first thing to find the inverse, I need to find what we call the determinant of t. So I'm going to say the determinant of t. And of course, you know, you go diagonal. Let me put my t here so we can look at it. You have 2, -1, 2, 0. Alright, so the determinant, you multiply the leading diagonal. You take the product of a leading diagonal. You take the product of a non-leading diagonal. And of course, you subtract them. So I'm going to have 2 times 0 minus -1 times 2. Now look what happens. 2 times 0, 0. 2 minus is there, which is going to give me a positive 2. So I have the determinant of t. Alright, good so far. Let me just break this up into parts so it goes as quickly as possible. Now, how do I get the inverse? T inverse is equal to 1 over the determinant of t times the adjoint matrix of t. And now let's put this into context. Simple for you. So I'm going to have 1 over 2 basically multiplied by the adjoint matrix. Now what do I do? Now let me rub this out right here and reduce the point. Easily put for you. We want to make this as easy as possible. The leading diagonal, which is 2, 0, you switch that. So you put the 0 up here and you put the 2 down there. And the non-leading diagonal, which goes this way, you simply change the sign. So that -1 becomes a positive 1, and that positive 2 becomes a -2. Now you have the inverse of t, which is t inverse, which now you're going to need to multiply this inverse by a inverse. Alright? So, by a prime, sorry. So you're going to have a half, 0. Oh, good. I don't even need to go to that far because they're saying determine the matrix. We now have the matrix. Alright, so what I can do is that I can condense this, which is to multiply everything by a half, because this is the matrix. So what you can do, is that as a part of your notes, if you multiply a point A by a matrix to get A prime, and if you want to move from A prime back to the matrix, you have to multiply A prime by the inverse, because that is really the division form of matrix, to multiply by the inverse. Alright, so if I tidy this up, you simply take a half of everything in here. A half of 0, 0. A half of 1 is a half. A half of -2, -1. And a half of 2 is 1. So this would be my transformational matrix right here. Alright, 0, half, -1, 1. And that would be the end of that question. Alright, I don't think I have any more questions on this page, so I'm going to go to the next page. Alright, this one says another transformation P is defined by the matrix P equals 0, 1, 1 minus 2. Find the single 2 by 2 matrix that represents a combined transformation of T followed by P. Now, I want you to understand the context of what is happening here. The matrix that you're going to perform first is T. So let's put T down. Now, let's go back up. Let's go back so we can look back at T. T is 0. Well, T is 2, -1, 2, 0. Alright? So I'm going to have 2, -1, 2, 0. So this is the first, if you are going to multiply, if you're going to transform something with this matrix, or with these matrices, this is the first one you'd multiply the matrix by. So let's pretend that there's a matrix out here, call it AB. Then after you multiply by this matrix, you're going to multiply by matrix P. So P has to be at the front. Alright? Because you'd have done this first and then you multiply by P. Now somebody might be asking now, why is it that I can't put it anyway and it's multiplication? Very good question. Because the multiplication of matrix is not commutative. Now in maths, in regular maths, with arithmetic real numbers, you know that A 2 times 3 is 3 times 2. That rule does not apply to the multiplication of matrix. Very important that we know that. So it's not that I can put any one of these matrix first. I can't do that. Alright, it has to be in a specific order. So because I'm going to be multiplying, I'm going to be performing matrix T, it goes right there because whatever coordinate I have, it would multiply the coordinate first. And then after I do that now, I'm going to multiply by P. So that is why P is to the left. And I can't switch it around, I will not get the same result. So what they're actually asking me to do now is to give the product of these 2 by 2 matrices. Now what's the easiest way to do this? Alright, you know it's row by column. Now to make my life very easy, I am going to look at the first row, which is 0, 1. I'm going to count the amount of columns here. So follow what I'm going to do. Since it's row by column, I'm going to put down the first row, which is 0. I'm going to put an open bracket, plus 1, and I'm going to open the bracket again. Now I'm going to have to skip some space and do the same thing because I have a second column. So it's going to be row 1 times column 1, and then row 1 times column 2. So we skip a space. So we're going to have 0, open bracket again, plus 1, open bracket. Alright? We'll go to row 2 and we'll do the same thing. Now you don't have to do it exactly like this. It's really up to you. We'll go to row 2 and we'll do the same thing. So I'm going to have 1, open bracket, minus 2, open bracket. And once again in the second matrix, I have 2 columns. So I do the same thing. 1 open bracket, minus 2 open bracket. I do it like this because it becomes a pattern. So I can't really make any mistake. So when I go to the second matrix now for the column, the first column is 2, 2. So all you're going to have is 2, 2. And you do it down here as well. 2, 2. Column 2 is negative 1, 0. So you're going to have negative 1, 0, negative 1, 0. You can't make any mistake like that, alright? Now, for the answer. Alright, here we go. Now, 0 times 2 is 0, plus 1 times 2 is 2. 0 times negative 1 is 0, plus 1 times 0 is 0. Of course, 0 plus 0 is 0. 1 times 2 is 2, and 2 minus 2 times 2 is 4. 2 minus 4 is negative 2. Now remember, you can use the calculator to quickly do this, so you don't waste time on this. Alright? 1 times negative 1 is negative 1, and then you have minus a 2 times 0. You know what happens when you multiply 2 by 0? That's 0. So all you have here is really minus 1. Alright, so that's my combined, this represents my combined matrix of T followed by P. Alright, so you have 2, 0, negative 2, negative 1. Alright, good. Now it says, find the image of the point 1, 4 under this combined transformation. Very good question. Because once you're finding the image of a point under combined transformation or any transformation, all you really need to do is to take the transformation of the matrix, which is 2, 0, negative 2, negative 1, and multiply it by the position vector of the coordinate. So I'm going to have 1, 4. And bear in mind that I can easily transition between position vector and a coordinate. Alright? The only thing that is different is the form in which we write them. So here's the next multiplication of matrix. Alright? And you know it's row by column again. So the first row here is 2, 0. So 2 times something plus 0 times something. You notice I only do it once as opposed to the previous scenario because it's one column in the second matrix. Then I'm going to move to row 2. Negative 2 times something. And then this is a minus 1. So minus 1 times something. I'm not going to put a plus minus 1 because a plus minus 1 is a minus 1. Now I put in the column over here. And the column is 1, 4. So I'm going to have, probably I should even use a different color to make you see it. 1, 4, 1, 4. So this now becomes 2 times 1 is 2, 0 times 4 is 0, so all you have is 2, and then negative 2 times 1 is negative 2, and then minus 1 times 4 gives me a minus 4. So you have minus 2, minus 4, which is minus 6. Once again, calculator works nicely, but this is in its vector form, or its metric form. So I want it in its, it says find the image of the point. So I want it back as a point, which means I'm going to put it as 2, comma, minus 6. That is how it looks as a coordinate. Alright, very important that we understand the concept here. Alright, let's go to the next question. Alright, here we come upon a vectors question. It says the diagram below, not drawn to scale, shows a quadrilateral A, B, C, D, in which AB equal to M, as you can see here, and follow the direction of the arrow. AB is the arrow is going from A to B, very important. DC equal 3M, as you can see here, and AD is equal to N. Now, of course, if you have a vector M, and you have a next vector which is 3M, of course, how vectors work, once one is a scalar multiple of the other vector, right away, we automatically know that these two vectors are parallel. Once you can multiply one vector by something to get a next vector, it means that the two vectors are parallel. Alright? So AB, which is this vector, which is M, and DC, which is this vector, which is 3M. Notice that 3M is really 3 times M. So for that to happen with vectors, they must be parallel. Alright? So we say that they are parallel. Now, the modulus, very important that we know that sign, the modulus, also called the length of AB, is dash times the modulus of CD. Alright, well, let's switch it around, CD or AB. Modulus does not consider the direction that the vector is going, because the modulus or the length cannot be negative. So it doesn't matter if we turn it around, still the same thing. The modulus of CD and the modulus of DC, same thing, because it's a length. Alright, it only has magnitude, or we call it a scalar quantity. So one is M and one is 3M, so it must be 3 times. Alright, so AB, well, it says AB is dash times DC. It's going to be 1/3, because we can say that if we multiply AB by 3, if we multiply the modulus of AB by 3, we get the modulus of DC. So when you turn it around and say that AB is dash times CD, it's going to be 1/3. Alright, and let me make it make sense for you. The modulus of DC, and persons would probably better understand it this way, is equal to 3 times the modulus of AB. In other words, the length of vector AB, if you multiply it by 3, you get the length of vector DC. So when I say AB, modulus of AB is dash times CD. Since you have the 3 over here, we would have divided both sides by 3. So AB, the modulus of AB is the same thing as saying DC, the modulus of DC over 3. And we know that whenever we divide by 3 is the same thing as saying 1/3. So that's why we have 1/3 there. Alright? Now let's take this down. It says express BC in terms of M and N. So I want to go from B to C. Let's put the arrow there. I'm going to start at B and I should end at C. So what route it seems that I'm going to have to take to go from B to C? It seems that I would have to go from B to A, then from A to D, so plus AD, and then from D to C. Now what is important is that once we go the opposite direction of the arrow, the sign becomes a negative. So because AB is M, but I want BA, it automatically becomes a minus M. AD was already N, so it keeps the sign, it's going the same direction as the arrow. What about DC? The arrow is going in the direction of DC, so it becomes 3M. Now it is important that I know that I must group my like terms. Alright, so I'm going to have minus M plus 3M. All right, you owe 1, you have 3. You pay that one that you owe, you're going to have 2 left. So I'm going to have 2m plus n. Can't go any further, so that's how we leave it. All right, and there are no more questions on this page in 2018, so we take ourselves to the next page. All right, it says L is the midpoint of CD. Find BL in terms of M and N. So L is the midpoint of CD. Find BL. So let's go to the previous. We're going to pull this back down. We want BL. So we want to go from B to L. Notice the arrow. B to L. All right, very good. Now, bear in mind that this is the midpoint right here. L is the midpoint of DC. So whatever DC is, L is in the middle of that. So if I want to go from C to L, it's half the entire length CD. And if I want to go from D to L, it's half the entire length of DC. So whichever way you want to go. What is important is the sign. Now notice that we found BC already. Found BC. So I can choose to go BC, B to C, and then C to L. Or I can choose to take the route that I did already, go from B to A, go from A to D, and go from D to L. It's really up to you. Probably most persons would probably take the route from B to A to D, and D to L to avoid dealing with the complexity of BC. But let's take BC because I have to learn how to do this, right? So probably I could say I go from B to C and from C to L to get BL. So let's go back. So I can say BL. I'm going to go from B to C and then from C to L. Now guess what? The beauty of this is that I've already found BC. So previous. I know BC down here. Let me remove this. Let me bring this up so it's out of our way. BC, if we take this down a bit, let's take this down, was 2m plus n. Alright, so let's go back and put that. BC is 2m plus n. We have that already. What about CL? Alright, good. If I'm going from C to L, that is half the route from C to D. But I don't know what CD is. I know what DC is. So we know that if DC is equal to 3m, then of course what? CD must be equal to negative 3m. Now if the entire thing is negative 3m, if CD is negative 3m and L is halfway, it means that if I'm going from C to L, I'm going half of going CD. So we're simply going to say a half. So CL is basically a half times CD. Alright, let me go back to the next page. So plus a half times CD, which is a half times negative 3m. Alright, and then I can put back my 2m plus n here. Now let's see how this works. You have 2m plus n. Now a half times negative 3 is going to really be minus 3 over 2. I don't need to put back the, I'm not going to put back the plus minus because, you know, positive times a negative is really a negative. So I'm just going to put back the minus 3 over 2m. Alright, you can use your calculator. You can't go wrong. Now I'm looking for like terms. Let me group this. So I'm going to have 2m minus, this is a minus not equal, minus 3 over 2m plus n. Alright, now your calculator can do this for you. Remember now, whenever you subtract terms, you subtract coefficients. So it's really 2 minus 3 over 2. Or 2 minus 1.5, which is really going to leave you with a half m. And you put back your plus n. And that brings you to the end of the vectors and matrices question for 2020.